Oh, I am live. Yep. Yep. Let's just, yep. That's great. Let's put that down. Excuse me. Welcome to a tangent series from the Unreal Engine by example spin-off show. Instead of continuing with the Unreal, volume, please. I know my stream makes sound. I just have to make sure it doesn't crash. That's the main issue. So we hit a small hiccup in the Unreal Engine 4 by example stream by the fact that it moved breakneck speed into C++. I'm not very good at C++. Welcome to Math Noise Stream. I did a lot. I did some. I did a little bit of. I have seen C before. Let's dig out of this hole. I took I enrolled in the CS50X in like 2014, I think. Maybe it was even 2013. I think it was 2014 now. And I never finished all of the modules, so that looks bad already. But I got far enough to. Is this thing ever gonna connect to chat, or is it just gonna dick me around with this? YOLO. Damn. So I can't see chat apparently. That's good. I guess I can look at chat on my phone, I guess. I can check the chat on my phone, and I can see that it has updated the title and tags from OBS Studio, but for some reason the chat just is not connecting. Cool. So anyway, I thought it would be a good idea to ask some of the lovely people in some of the, areas of the internet. I had a whole bunch of errors last time. This. I spent like 3 hours just screaming errors rather than trying to fix them. I mean, I was reading a lot off screen, but it wasn't good for you guys to watch, was it? It was pretty boring. It was frustrating for me because I can't make headway unless I know what I'm doing. I didn't know what I was doing. I was literally, fucking clueless, and it's not good. So in an effort to become unclueless, we will be going through the book C++ Primer, which was written primarily by Stanley B. Lipman, but also assisted by Jose. Is that Jose or is it Josie? LaJoye and Barbara E. Moo. Which is a book which covers the C++ coding language in some 1,300 pages of text. It was recommended to me by the lovely patrons on someone's Discord. And yeah. We'll be going through that book. I'll be writing some example code, and I will be learning in depth. Maybe not in great depth, but in some depth, at some level, the C language. So the first thing that I notice is they said working with a was a VDE, a visual development environment, or a VSE. I can't remember what terminology they were using exactly, but using or an IDE. Was it an IDE? Anyway, using one of these. This is Visual Studio 2019, and it allows you to arrange coding projects into different files, and it will do certain levels of automation, like the external dependencies folder has a whole bunch of header files for the project which we've created, which is just Hello World, which is good. It's great. It's really handy that you have a tool that will... Whoa, what was that noise? Big slimes. It's great that you have a tool that will speed up some of the processes of writing code in any way, shape, or form. This is a good thing, because writing code can be tedious. It requires meticulous memory of naming things that you make and things that you will need that other people have made. And Visual Studio itself, specifically Visual Studio, I don't know about any other IDEs. I know that well, I know about Notepad++, and there was one other. Was it CPAD or something? It was a Linux program. Anyway, Notepad++ has visual cues. You know, you can see that the stuff here. If I can kind of just it's Alt to whoa. Whoa. Ooh. If I can, yeah, thank you, thank you, thank you. You can see here that the code has some color to it. Sharp include is grayed out because it's a sharp include standard io.h. It's orange because it is a string. Int is a type, and int main bracket in fact has a call out all of its own, which oh, you can't see that because I've panned it off the friggin' thing. Never mind, we'll come to that in a second. Int main has a call out, which you can see, because it has its own function, because it's a very special function. Int itself is blue because it is a type. Indicate, which is they called indicators, and main is orange because it is a function, and we have return and 0. 0 has no color, it is just gray. Seems slightly green. I can't tell. Even on my 120% sRGB, whatever the fuck that means. So you can see, as I was saying, over here. Hello. Hello world.cpp has got a breakout here in the Solution Explorer for main. Main is a function which can only be defined once per program. It is the core functionality. What was that? The core functionality of the program itself. Hey. And yeah, so I wrote this actually off stream. I wrote this just to see what was going on, and one small hiccup that we have with using Visual Studio is that rather than working and compiling CPP files into .exe files, the default setup of Visual Studio is that a stock fucking pixel? No, that is displayed. That is data. That is not a stock pixel. Okay. So the way Visual Studio works is that it will create a project for you. Your project will have a folder for the external dependencies, the header files, the resource files, and the source files. The source files, you will have your one main CPP file for the functions. You will have maybe CPP files for external functions, stuff that you will put in header files, classes, things which are not your program but are still C code. And it will, when you click this button, it doesn't compile your program, it builds your program, which means it compiles all of your C++ files, and then it takes the outputs from those compiled programs and it puts them together, I guess, with respect to the main source file. Anyway, it just means that if we want to do different things and have this saved in a file of its own or a folder of its own, you could just take the CPP out of the folder and move it somewhere else, I guess. But starting a new project is what would have to happen. Anyway, this is the first example code in the CPP primer book, and it is a simple, almost too simple. In fact, this is beyond simple. Piece of code which prints. It doesn't print. In fact, it outputs to the Windows console the number 0 as a return code. So when a program completes, when a function completes, it will have a return. And that return type is signaled in the definition of the function, right? Int main, it returns an int. The int it returns is 0. The 0 is typically used in C and C++ to indicate that everything went well. You can also use different return values which can be passed to the function caller outside the function. Which can be useful if you have a function that does a thing and then returns a value back to the main program. Can do. This return style is basically just open up the Windows console, run the program, and the program returns 0. When it's run, it closes the program and tells Windows that it has completed itself with a 0, which is usually the error code for no errors. But enough talking, you want to see this beast in action. Press F5, it builds, it runs, there we go. G++ CPP, baby CPP, hello world, debug, hello world.exe, process 14888, exited with code 0. Has returned 0 to our console. To automatically close console when debugging stops, enable tools, options, debugging, automatically close console when debugging stops. Press any key to close this window. So it's completed everything that it has been told to complete, and that's good. But that's ultra basic, and we were wrestling with so many more dependencies in the Unreal Engine stuff. It was untrue. Very scary. Yeah, here we go. Writing a simple program. Oh, this doesn't even need standard io.h. Okay. Chapter 1, getting started. I don't like this phone. It's gotten so old that the swipe scrolling, I wonder if there's a new Android update for it. But the swipe scrolling, basically, if your thumb leaves, it doesn't animate the swipe. It just like jumps to where it would stop, so you can't like interrupt it in mid swipe and stop it. Anyway, chapter 1, getting started. We have 6 actions. Writing a simple C++ program, which we've just done. First look at input-output. A word about comments, flow control, introducing classes, and the bookstore program. And the chapter summary. Define terms. Here we go. This chapter introduces the most basic elements of C++, types, variables, expressions, statements, and functions. Along the way, we'll briefly explain how to compile and execute a program. However, the C++, what's it called? Thing? I have the title right there. Primer. Whoa. Is not an IDE primer. It will not tell you about the specifics and ins and outs of your IDE. It recommends, I think, 2 compilers, and it recommends you do everything, or most things that you can tolerate, as much as possible through the command line because it's the most direct and most flexible way to use most compilers, like Clang and Bash and whatever else fucking stupid named compilers you have these days. I can't remember which one's it recommended in here, but I'd heard of one, I haven't heard of the other, and I'm pretty sure this one's using Clang, but we can probably check that. No, it doesn't have the it doesn't. We can't check that here. We'd have to check it in the settings menu. I cannot be bothered. It's information we don't need. We haven't designed the program yet. It's easy to see that we must define variables, do input and output, use a data structure to hold the data, test whether two records have the same ISBN. So the first chapter is about making a bookstore app, a program which keeps a track of ISBNs of books, or real or not. I don't care. I don't think this program cares either. It's non-contextual in that matter of fact. The price of each book, the number of each book which is sold, and then there's a couple of functions which I think it wants us to write about daily takings, how much money has been taken, or the average price of a book, or something stupid. Oh. So yeah, the example program it gives, apparently we don't need standard io.h to run this, so in the interests of science, or what do you know, it still works. So standard io.h deals with a whole bunch of things which are very useful for C and C++ programs. It has a whole bunch of functions for text. I think I saw it defined here as fprintf, but I know it as printf, which is the same as cout, if I'm not mistaken, or it's similar enough. It prints text to the console. But it also has a whole bunch of text commands, like scanning across strings, and analyzing strings, something like that. It has some dedicated text analysis stuff that you were required to kind of write programs for. It was really weird. We were given a when we did CS50, we were told that the standard io.h that we were given. Oh no, that's not correct. It was CS50.h that had the weird functions in it. Okay, never mind, ignore me. But I know it's got some stuff which is helpful, and some stuff which I'm pretty sure they tried to ask us to write anyway. So the only statement in this block is a return, which is a statement that terminates a function. As this case here, a return can also send back a value to the function's caller. When a return statement includes a value, the value returned must have a type that is compatible with the return type of the function. In this case, the return type of main is int, and the return value is 0, which is an int. Well done. So we've cleared chapter 1, part 1. Key concept types. So we've got the key concept for the first chapter, the first part of the first chapter are types. So we have int, we have char, we have string. Tentatively, string itself is not a defined type in C. A string is a defined type, which is an array of chars. There you go. Which is why string can also be written, or when you have is it standard io.h, or was it CS50.h? If you have a if you have a header file which defines a string in the way that it was defined when we were using the string functions, the string definitions, etc., you could also define a string as a char star, as that's what it was. It was a character pointer to an array. It was a character pointer to the first. It was a pointer to the first character in the array of characters. Something. Yo, man, it's been a long time. I'm just gonna stop talking. I'm gonna start reading. Whether you used a command line interface or an IDE, most compilers expect program source code to be stored in one or more files. Program files are normally stored as source files. Good, yeah. CC, CXX, CPP, CP, and I don't get why the C is capitalized in just C, but all the other C's are lowercase. It's weird. Yeah, there you go. I'm going to be using an IDE for interfacing with the Unreal Engine, so I am going to skip over most parts of this book which talk about command line compilation, command line running. I think if we go to our folder, we should have hello world is a 3D object apparently. You sure about that? Oh, what the fuck? That's a B. Nice. Thank you. Oh, there it is. Application. Boom. Yep. We'll just assume it worked fine. Because obviously the second it runs, it closes itself. So it's not a very useful program. First look at input-output. C++ language does not define any statements to do input or output. Instead, C++ includes an extensive standard library that provides input and output. Many other facilities. Yep, thank you. For many purposes, including the examples in this book, one needs to know only a few basic concepts and operations from the IO library. Most of the examples in the book use Iostream Library. Okay. In the Iostream Library, there are two types, named iStream, OStream, input stream, and output stream, of course. A stream is a sequence of characters read or written from an IO device. The term stream is intended to suggest the characters generated and consumed sequentially over time. Great. So, yeah, IO is IO. Well, you may, in the modern age, consider IO to be specific pin layouts on an Arduino. Maybe you could think like that. IO also covers internal I and O, so reading and writing from a hard drive or RAM. Oh my god. Or a disk or a USB device, etc. So the USB device would be the closest thing conceptually to having wires running off an Arduino. It's something that's not within the host kind of computer thing, but at the same time, if you think about it, hard drives are simply connected to the computer with cables, so I guess it's the same. It's just it's how you consider it. Anything that goes into the processor basically or out of the processor is IO in this instance. Here we go. Oh, I was using the arrows the wrong way around. Right, okay. So go back to BBC. Yes, that works perfectly. Thank you. Jesus. I'm always worried about creating projects like that because sometimes, you know, it doesn't. This is how I have learned. I stumbled across this by accident. I can't call it iostream.cpp, can I? iostream.cpp, boom. Yeah. So Iostream is weird. It's not a header file. The fuck's up with that? Yeah, man. What the fuck is up with that? Sharp include Iostream in main brackets. So one thing I've noticed, from C to C++ is int main brackets is fine. In C, we always did int main void. So I wonder if that works. I mean, it saves me 4 keystrokes if it does. I mean, if it doesn't, I mean, what? No, I mean, it saves me 4 keystrokes anyway. But I mean, if it does work, it should work, because as we remember from our previous lessons, C++ is a superset of C, and therefore all C code is valid C++ code. So this wants me to do int main curly braces. So yeah, I was looking for these because I remember doing C programming What does that even do? So let's look at what we've got there. Standard C out, left arrow, quotation mark, enter 2 numbers, yo, colon, quotation mark, left arrow, standard, colon, endl, semicolon. So semicolon indicates the end of the line, the end of the it's not a function, but the end of that piece of code. Whatever it's doing, the semicolon tells it that is the end of that instruction. And so what have we got? We got standard C out, so Iostream standard console out, so that writes something to the console, and that is going to be in the quotation marks, enter 2 numbers, yo. And then it's going to end the line. I'm guessing endl is the same as that, not namespace. Thank you. Obviously we're working in C++, so \n might be deprecated in typing because it may have been superseded in some circumstances, which is why I brought up namespace rather than the so there you go, enter 2 numbers, yo. So as you can see, our program has run. It has given us enter 2 numbers, yo, colon, and then a new line. Yeah, so end line is the same as \n, gives you a new line. Yeah, that's cool. See, I was the reason I started this stream so late is because I was worried this was going to be like difficult. Not difficult, but you know what I mean. I like learning, but I don't like learning. And V1, please. Can you do that? That's so fucking garbage. I do like. Oh yeah, okay. Numbers are slightly green. They're not. They're not. They're not colorless. So we do our text, and then we are initializing some variables, variable 1 and variable 2, which are both of type int. In C++, you can separate the definition of multiple variables of the same type with a comma in between the declarations, which is very handy. In regular C, you had to write out a declaration for each one. Again, another great way C++ saves you on keystrokes while regaining the core kind of values of C. What the fuck did you just do? Ah, I've missed out a code. Why did you get rid of my indent though, you fucker? You fucker. I'll solve you. So, it is, to my understanding, I know what this does. Standard cin requests input, and then I'm just assuming that STD stands for standard. It usually does in C. Like stdio is standard IO. But Iostream is a different IO. Anyway. So this is asking for user input for v1 and v2. It will get 2 user inputted values, and it will assign v1 and v2 to those values. I think that's what it does, and I'm pretty sure that's what it does. So I don't really know why, but we will get there. We will write the code first, and then we will understand the code. Why are you still yellow, you fuck? Ain't nothing wrong with that code. So yeah. Okay. So what this is going to do is it's going to open a console. It's going to type in enter 2 numbers, yo. It's going to display that to the dude sat at the computer as me. And then it's going to ask the user, it's going to initialize these 2 variables. It's going to ask the user to put variables in here. And then it's going to print into the console again the sum of variable 1 and variable 2 is the sum of variable 1 and variable 2. Whatever you typed in, it will add them together and it will put that in there. And then it will end the line again. And then it will return 0 because it'll run fine. And it'll all be good. So let's just see what happens then. We'll get this. 12 and 13. The sum of 12 and 13 is 25. It works. It works. No spaces, yeah, between any of this. Whoa. I hope that works. Just brute forcing some spaces in there. Yeah, it's nice. The sum of 33 and 34 is 67. Is that right? I'm sure that's right. That's pretty cool. I'm happy. I know I said yesterday that today might have been a double header stream, but next week will be a double header stream. I started late today, and this is all I'm gonna have time for tonight. I think maybe just an hour of this, a nice relaxing hour in the night time. Good. Anyway, let's read the plenary of this lesson. I don't know if we're at the plenary yet, but I feel like we are. It's section 2. It was telling us how to use Iostream. So the first line of our program include Iostream. Okay. So yeah, the sharp include Iostream includes the Iostream header. Apparently the Iostream header is so important that it does not need the .h. In fact, putting the .h breaks it. Writing to the stream. First statement of the body, the main executes an expression. That's what they're called. Expressions. Okay. Expression yields a result and is comprised of one or more operands. Cool. Today we're using the double left arrow operator to print a message on the standard output. Okay, cool. The double left arrow operator takes 2 operands. The left hand operand must be an Iostream object. The right hand operand is a value to print. The operator writes the given value on the given Ostream. The result of the output operator is its left hand operand. Okay, that is the result of the Ostream on which we wrote the given value. Right, okay, so this, oh, sorry. Good, namespace standard. Search that online maybe. So cout and cin, console in and console out, is the area into which we are going to be shooting our data. That data is on the other side of the arrows. The biggest question for me, I mean, obviously that's just how it works. You can just string as many of these double left arrows together as you need. I saw this in a it wasn't Python, what was it? Please help me. There are so many languages to remember the name of. I can't remember shit these days. Like I thought my memory was bad like before, but now, oof, Jesus Christ. It's like I can't remember anything. JavaScript had a very similar way of doing this. It was I can't remember the word he used to describe it. It was like injunction or truncation. Neither of those things are the right word, but it sounded like somewhere in between those two words. Anyway, it was basically just how you could put variables into strings of text. In fact, it wasn't this. This is the old way in JavaScript of how to do it. The new way was to have your full text string, and in the text string you wouldn't have these. You'd have ampersands, which would reference the variables to your stuff. Obviously, I don't know how that would work with actual kind of mathematics, because right there you've got an extra expression. So you've got expressions within expressions here. So it's fine to include variables within you know, a string, make them a text thing and print them to a thing. But here you've got an extra expression. I'm not sure how that would have worked. Why are we talking about JavaScript? We're here to do C++. Anyway, yeah. Each operator in the chain. Here we go. The first operator prints a message to the user. That message is a string literal, which is a sequence of characters enclosed in double quotation marks. The text between quotation marks is printed to the standard output. So a string literal is just a string. Okay. Someone's going to be raging in the VOD. They're going to be like, string literal is not a string. The second operator prints endl, which is a special value called a manipulator. Writing endl has the effect of ending the current line and flushing the buffer associated with that device. Flushing the buffer ensures that all output the program has generated so far is actually written to the output stream, rather than sitting in memory waiting to be written. Okay. However, double ironically, because this... Are you fucking kidding me? On stream. Not only does Visual Studio want to be updated, but Windows is like, I want to update too. See? Look at that shit. Everybody wants updates. So that's pretty cool. Endl doesn't do \n's job. Endl is a thing which does IO stuff. Very powerful. Not like \n, which just gives you a new line. Okay, so \n should still work. Jesus. Warning, programmers often add print statements during debugging. Such statements should always flush the stream, otherwise if the program crashes, output may be left in the buffer, leading to incorrect references about where the program crashed. Right, okay. So endl forces the data which is in the current memory to get slapped into the whatever cout you've got. Obviously cout is a specific out, but whatever output you're writing to, if you put an endl there, it will not progress your program. It will stop your program, and it will push all of the data that your program has got in the memory to be written, and it will write it. That's pretty cool. Also, pretty dangerous. I mean, debugging is great, but actual program... Using names from the standard library. Okay, so we can use... Careful readers will note this program uses std, ::, cout, and std, : endl, rather than just cout and endl. The prefix std indicates that the names cout and endl are defined inside the namespace named std. Namespaces allow us to avoid inadvertent collisions between the names we define and uses of those same names inside a library. The names defined by a standard library are in the std namespace. So that's another thing which I was really wondering about. So when I first started learning C++, not C, I'm definitely talking about C++ now, on Solo Learn, great platform for getting into coding, but a horrible platform for actually learning anything. Sorry, I don't want to like roast them right now, but you know, the ability to learn is not within the app, it's within the users itself. And I found it helpful to a point. It was great to get a taste for a language, you know, to I am just not connecting to chat today, am I? Can I even... It's got all my recently used emotes. Oh, okay, I cannot chat. What was I talking about? Yeah, I was wondering about these because when I was learning, yeah, going in a circle, that's talk in a circle. When I was learning C++ for the first time, we did not have std : We were using cn and cout directly from the Iostream. I don't know if it was from Iostream. We didn't use, because you don't have to write example code when you're doing solo learn. You just drag and drop little fucking niblets into the correct location, which just anyone can do that, even if they don't. If you have to pay attention to what you're doing. And solo learn is not an environment which makes you pay attention to what you're doing, so you end up learning less than what you think you're learning, which is a big shame. Another thing that would help solo learn be a more efficient learning tool would be narration. Absolutely. Like, there's like 4 different types of learning person. People who learn by reading, people who learn by doing, people who learn by seeing, people who learn by listening. And you know what? Reading is not the way I, if I see stuff and it's, I can just put the answers into the right boxes. Yeah, I can put all the answers into the right boxes. I don't feel like I'm learning. And if I don't feel like I'm learning, I don't really see the point in continuing it. Even if I am learning, if I don't feel like it, it's like, whatever, man. But reading as well, it's a fucking chore. I hate reading. Reading's so stupid. Reading from a stream. Having asked the user for input, we want to read that input. We start by defining 2 variables, good. We define these variables as type int, good. We initialize them to 0, good. We initialize the variable, we give it the indicated value at the same time. The variable is created, good. Next statement, standard, colon, cn, double right arrow v1, double right arrow v2. Reads the input operator, the right arrow operator, behaves analogously to the output operate. What? Yeah. It takes an Iostream and its left hand operand as an object. It takes right hand operand. What? It takes an Iostream as the left hand operand and an object as a right hand. Okay, yeah, okay. So wherever the input is coming from is here, and then wherever the input is going to is there, right? So obviously the input's coming from the console. You type into the console, you press enter, and then it puts those inputs to wherever you tell it to, and these are being told to be put into variables, and the variables exist. The variables are ints and they're initialized, and that's great. I don't want to talk about the inherent flaws to this program, but because that takes us out of C++. But while I'm skipping ahead here, may as well go ahead and say, what happens if you type letters instead of numbers? What happens if you type floats instead of ints? Do you know what? Small break. Let's just do that. Let's just see what happens. Yeah. Hi. A. Damn, son. Okay, so A skips the whole program entirely. Okay, so letters aren't even read by their binary, what do you call it, ASCII codes as number. They're read as letter. Oh, we have diagnostics going on. Wow. 902 kilobytes, that's a lot. That's a lot for what we're doing. That's really interesting. So enter 2 numbers, 12.5, 44.888. The sum of 12 and 0 is 12. So what it's done is it's taken the 12 and then everything to the right of that dot has just been fucking garbaged. Interesting. It's not what I expected. I expected the program to hang and then crash, but whatever. It's nice. easy input the operator. Yep. Hence, this expression is equivalent to because the operator returns its left-hand operand, you can combine a sequence of input requests into a single statement. Our input operation reads two values from standard cin, storing the first in v1 and second in v2. In other words, our input executes as standard cin v1, standard cin v2, completing the program. What remains is to print our result. We print our result. It's great. With extra white space so it looks good. Explain whether the following program fragment is legal. This is where I pull out my analysis cap. Standard : C out, double left arrow, the sum of, double left arrow, v1 : double left arrow, and v2. No, it's not legal. There are semicolons inside your line of code. That will not work. That will abort your code. That will stop doing things at v1. You would need a second standard C out if you wanted to do that per line, right? So I'll show you what they've got written. They've got a semicolon here, and they've got a semicolon here. That's all the semicolons they've got. As you can see, Visual Studio has already gone, yes, fuck you, bro. Yeah, errors. And that's because semicolon ends the function, and there were no extra declarations of standard C out. So if you had your semicolon here, and you had a new line, you don't actually need a new line. White space to the compiler is not important. White space is only important to humans. So all this could be on one line. And yes, your eyes would bleed looking at it, but the computer's eyes wouldn't bleed because the computer wouldn't have to navigate all this fucking white space, would it? Anyway. So if you had a semicolon here, you would need another standard C out after it. And then if you had a semicolon here, you need another standard C out here to do the functions which you have semicolons applied to. As you can see, the only semicolon in this line as it stands is right at the end when we finish doing our expression. So yeah, no, not valid, not good code. If this program is legal, what does it do? If this program is legal, why not? How would you fix it? Well, just been through that. Thank you very much. I'll take my I had a couple of other things where it wanted us to do this thing, wanted to write us this program, but instead of adding together, we did multiplying, and that's just that, right? Entity numbers 2 and 6 are 5. Okay, the sum of 2 and 5 is 10. Now it's a comedy program. Thank you. How do you spell Fibonacci? Like that? I gotta look this up. Anything with double letters in I spell wrong. Fibonacci. Fibonacci. There's no I in Fibonacci. It's Fibonacci, not Fibonacci. And it's capital F. This is a super dank inside joke. I'm sorry. Oh God. There's so much wrong with this program, and none of it is the same. Another insane cringe fest restoration. Oh, I want to watch that video. It's the Guitarologist. It was published 12 hours ago. MacBook repair. I'm on a plane to Washington and sitting next to someone who smells bad for 6 hours. Yeah, rip. Rip Louis Rossman. Published a video 3 mins ago about someone smelling bad. Oh. You can't nest comment pairs. Wow. Why would you ever want to, though? It's a comment. You can't nest comments. Do you want to nest a comment? If it was a social media thing, I'll get that. You nest comments. They're like because it's a back and forth. But this is a monologue. Code is not dialogue. It's monologue. Just think about that for a moment. We often need to comment out a block of code during debugging. Because that code might contain nested comment pairs. The best way to comment out a block of code is to insert single line comments at the beginning of each line in the section we want to ignore. Everything inside a single line comment is ignored, including nested comment pairs. Ah! That's useful information. Thank you. Compile a program that has incorrectly nested comments. Why? Indicate if any of the following output statements are legal. So the first comment statement is, the output statement is standard cout output open quotations /* close quotations, semicolon, that should print. Standard cout output quotation * end quotation semicolon, that should print in isolation from the last one. Standard cout, that is a commented out function that will not print. And the next one is also a commented out situation that will not print either. Yeah. So the first two are fine if they're in isolation from each other, because the quotation marks require anything inside the quotation marks to be printed unless it's an escaped character, and escaped characters do not begin with /, they begin with backslashes, like \n, \t, or v, I, ampersand. What? Flow of control. Statements normally execute sequentially. First statement in a block is executed first, followed by the second, and so on. Of course, few programs, including the one to solve our bookstore program, can be written using only sequential execution. Instead, programming languages provide various flow of control statements that allow for more complicated execution paths. While statement repeatedly executes the second of code slog. This isn't what I thought it was going to go on to. I know what loops are. It's not loops. I thought this is going to go on to multi-threading and asynchronous computation, which was something that was covered in a very tasty book that I read and no longer have use for, Mastering Python by Pact. Good book. Great book if you're into Python. A lot of good tips, and it has a whole big old chunk completely devoted to asynchronous processing and multi-threading. Sharp include Iostream. Int sum equals 0, val equals 0, while val is less than or equal to 10, sum plus equals val. Assigns sum and val to sum plus val. Sum of 1 to 10 inclusive is and then outputs. Okay, so it's a basic little addition statement that we can get our heads stuck deep inside. While oh Jesus, the reflection of my mic cable in my phone screen was just poking directly into my eyeball there. Nice. I've got a spot on my fucking face. While executes by alternately testing the condition and executing the associated statement until the condition is false. The condition is an expression that yields a result that is either true or false. So as long as the condition is true, the statement is executed. After statement is again, wait, what? If condition is again true, the statement is executable. While continues alternately testing the condition and executing the statement until the condition is false. So If the condition becomes false, it will not execute and it will move to the next step. If the condition is false to begin with, it will not execute and it will move on to the next step, which is when we use a do while. If it's going to be false, if there's the potential for the while to be false instantly, but you want whatever it is inside that code block to run once, you can use a do while loop. So you have your do code, and then the while is at the end. So that will do the code once, and then it will kind of look at what's gone on, and then it will decide. Whereas the while loop will look at what's gone on first, and then move on. Right? Am I right? Am I wrong? Sum equals sum plus val. Sum plus equals val. Yeah, great. Plus plus. Yeah. Uses while the sum of the numbers from 50 to 100. Oh no. Absolutely not. This is one of those fucking Fibonacci fuckers. You know, Fib 36 is okay. It takes a couple of seconds, but Fib 37 takes a fucking millennia to compute. It's ridiculous. It gets exponentially slower because it has to add n more ones for each level. While we used variable val to control how many times you execute the loop, I tested the value of val in the condition and incremented val in the while body. This pattern using a variable in a condition and incrementing the value for the body happens so often that the language defines a second statement, the for statement, that abbreviates code and that follows this pattern. We can rewrite this program for a for loop to sum the numbers from 1 through 10 as follows. Int main int sum equals 0, for int val equals 1, val is less than equal to 10 plus plus val, sum plus equals val. Ah, for loop. Beautiful. Vanilla tasting. Succulent. For loop. For each for statement has two parts, a header and a body. The header controls how often the body is executed. The header itself consists of three parts, an init statement, a condition, and expression. In this case, the init statement int val equals 1 defines an int object named val and gives it the initial value of 1. The variable val exists only inside the for. It is not possible to use val after this loop terminates. The init statement is executed only once on entry to the for. The condition val is less than or equal to 10 compares the current value in val to 10. The condition is tested each time through the loop. As long as val is less than or equal to 10, blah blah, we know how for loops work. Create val and initialize to 1. Test whether val is less than or equal to 10. If the test succeeds, execute the for body. If the test fails, exit the loop and continue execution with the first statement. Increment val, repeat, blah blah. What does the following for loop do? What is the final value of sum? Int sum equals 0. For int I equals negative 100. I is less than or equal to 100. Plus plus I, sum plus equals I. That sum is... Oh, that's such a fucking stupid thing. It sums all the numbers from negative 100 to 100. Right? So it just equals 0 anyway. Right? That's so fucking stupid. Reading an unknown number of inputs. Oh, here we go. Here's something juicy that I don't know about. In the preceding sections, we wrote programs that summoned the numbers from 1 through 10. The logical extension of this program would be asked the user to input a set of numbers to sum. In this case, we don't know how many numbers to add. Instead, we'll keep reading numbers until there are no numbers to read. Yeah, that's fine. The value is just going to be the set. No, that's not. No. Bad. When we enter input to system from keyboard, different operating systems use different conventions to allow us to indicate end of file. On Windows systems, we can enter end of file by typing a Control-Z, hold down the Control and press Z, followed by hitting either the Enter or Return key. Unix, Mac OS, end of file is usually Control-D. Command-D if you're on iOS. Right. Mac OS X. You don't have a control button, right? You have a command button. Come on, dudes. Here we go. This is the error out after compiling the stupid code that they asked us to try and compose. I don't know. Use colon, not semicolon after handle. Okay. Similar. It's similar code. I just jumped to conclusions because it's getting late and I'm getting sloppy in the brain. Got some brain slop going on. I think it's, we warmed up. We wrote a small program that does exactly what it doesn't say. The if statement. So I think the thing to take away from this stream, I'm going to wrap it up here. The thing to take away from this stream for me, I don't care what you take away from this stream, apart from the fact that my brain's turned to soup, and I wanna move forward at a slightly different pace from now on. Anyway, the thing that I want to take away from this is standard C in, standard C out is going to be a useful tool for working with command line stuff, and the input output operators, the lefty boys, the righty boys. Why are there so many? Standard Iostream and standard Iostream operator. Standard Iostream and BFN standard Iostream. Oh no. And this is different, right? Standard Iostream, standard operator, standard cartridge. Sure, yes it is. So they are the same, and yet they are different because the endline modulator is there, I guess. It's cool. It's great that Visual Studio gives you these kinds of hints, clues. I like it. It's really nice. I like the way Visual Studio looks, and people are gonna fucking hate me for this, but Visual Studio looks great. Notepad++. If you can make the menu bar the same color that I want to make the rest of the fucking window, you gold. It's a great IDE, and I respect anyone who uses it, but having a white fucking menu bar at the top is just fucking. Anyway, so yeah, the thing I'm taking away from this is the use of Iostream, C out, C in, and these little input output doodabbers. Okay, so before we leave, let's just analyze these. These are standard outs which write chars. So okay, yeah, we see. So you can see that we've got standard operator, standard char traits, char, standard Iostream, and O star, O string, constant char star underscore val. So that is some C, maybe, that indicates that these output arrows, I really hate the way they face, but that's just the way they've done it. These output arrows output a char star or a string. You see right at the end there, char star underscore val being the maybe the name of the variable, and constant char star is a pointer, right? Pointer to a constant character array of the characters which we're putting in there, which is what we write in our C program. This is a function in Iostream.h, obviously. It's great. I'm sure it's great. We got inputs, we got outputs, we got a lot of fucking arrows going on. It's kind of hard to read, to be honest with you. But the next ones, the arrows in front of v1, v2, and v1 plus v2, or v1 times v2. Here we go. Standard OStream and standard OStream operator output int value indicates that we will be outputting an int data. So it seems that these are automatically labeled with the correct code on the back end, on the header, excuse me, depending on what we're doing. And this is, I see, I forgot what Endel did for a moment there, but yeah, this is so long because it is collecting the data that has been manifest, and it is printing the data as fast and as hard as it can to the cout. That's great. And let's just check the c-ins just to be, they're both ints, right? Yeah, c and int. Lovely. So we've learned a little bit about Iostream, which is good because Iostream might be useful in the future. I know it's making these console command programs is where a lot of people start in their journey of programming. It may not seem interesting or relevant to begin with because it's fairly basic, because it uses the console. It doesn't use a GUI, it doesn't use a 3D environment, but it is solid foundation to the C++ engine. Oh, nice. That is another thing about this, about the program, because it does return the second you hit enter. There were probably like, my CPU probably spanned like 8 times doing that calculation, and my CPU spins at almost 4 gigahertz, 3.8 million, 3.8 billion. Mega is million, right? Kilothousand mega, million, giga, billion. Yeah, 3.8 billion revolutions a second. My CPU is spinning, and it took like 8 or 10 of those revolutions to do that calculation. No time at all. In fact, faster than it took my GPU to render the frames to the screen because it's locked at 60 hertz. God damn it. Anyway, thanks for tuning into the live video. Sorry it was quiet. Sorry it was so late. And sorry it was so short. 1 hour and 20. And it was barely even an hour and 20's worth of... Ooh, barely even an hour and 28 minutes worth of actual content. No. Oh, you can minimize those. That's so cute. Yeah, thanks for tuning in if you did tune in. Thanks for watching the VOD if you came to watch the VOD. I hope you enjoy this, and I'm sorry I didn't have a follow-up stream. So after I do all this kooky, weird C++ garbo on Mondays, I intend to do a follow-up stream directly after doing Unreal kooky garbage, but not C++ stuff, Blueprint stuff, in editor window stuff, flashy visual stuff, textures and particle effects, etc., etc. And I hope you'll appreciate maybe a little bit of duality on the Mondays. We get the stupid text-based stuff in the early slot, and we'll have the stupid 3D based stuff in the late slot. Although I've only filled the late slot today. Ridiculous. I even think I'd have 2 slots on the same day. It kind of boggles my mind. It was daunting, which is why I haven't done it, and also because I had some other stuff to do and procrastination, yada yada. But anyway, that is it for today, and I will see you in the next episode.